Welcome to the R&D lab here at KEB America. Every day there are different tests going on here for various industrial automation applications. Today we're going to talk about how small mistakes in the commissioning process can cause large mistakes down the line. This can be from small desktop demos to large-scale machines in the field. The first issue is somewhat broad but critically important. It's to follow best practice EMI guidelines. This can include installing an EMI filter, spatially separating the motor and encoder cables, making sure to account for the motor power cable length. All of these and more can help prevent issues from electromagnetic interference down the line. Next up is the motor data. Most basically, it's to make sure that it's entered properly in the VFD. Somewhat more complicated, induction motors like this are often dual winding motors. That means they can be supplied either 230 or 460 volts. You'll want to make sure it's wired properly for whatever voltage you are supplying. Next up is the motor brake. It may seem obvious, but if the motor brake isn't opening, you're not going to be able to run the motor. A basic check would be to open the hand release and to spin the motor shaft by hand. This shows that the motor brake is releasing. If you're controlling the motor brake with a VFD, you should hear an audible click when supplying the voltage to the motor. If you don't hear this click, you may have an issue with the wiring from the VFD, the supply voltage, or other things to check to make sure that the brake is properly opening. The next common mistake occurs in the design phase, and it's not considering the regenerative energy of the application. If a motor is decelerating under load, or too fast, or from too high of a speed, it will be regenerating energy back to the VFD. If this is not accounted for, you'll get errors on the VFD. Easy ways to prevent this are with a braking resistor or a regen unit, which you need to make sure to incorporate those into your design. Another common mistake is trying to start the motor under load. Ideally, your first time spinning the motor, it'll be set up like this with nothing connected on the output shaft and no load on the motor. This ensures for a quick and easy startup and then can be easily adapted once the motor is connected to the machine and under load. The final and probably most common mistake is to skip steps while doing the VFD programming. It can seem like you're saving time initially, but it ultimately just causes headaches down the line. This could mean trying to do closed loop before open loop, or trying to do your position control before your speed control, or trying to go straight to max speed and max load before ramping up. By avoiding these common mistakes, you can ensure a quick and easy startup of your machine. If you have any questions, contact us at KEB America.